Hey everyone, this is part one of the topic called continuity. So if you look at this definition, the definition that we used junior year of continuity was that a graph is continuous if you can draw it without lifting your pen. According to that definition, let me erase this part because let's just not look at that. Okay, so in each set of graphs that I'm going to show you, so this is part A through D right now, there's one continuous function. So if you want to try to find that right now, the graph that you can draw without lifting your pen, see if you can find that. But part A is not continuous. I'm going to just abbreviate not continuous because if you were drawing it at 3, right at 3, you would be lifting your pen, right? You're here, and then you have to lift your pen to draw that second part. So part A is not continuous. Part B is also not continuous. There's always somebody who likes to be clever and say, I can draw this without lifting my pen. But the point is that there's a hole in the graph at x equals 1. So because you have that removable discontinuity at x equals 1, part B, that graph is not continuous. Part C is also not continuous. Again, there's a hole in the graph at 0. It is defined down here, but that's still lifting your pen from the paper. You have a hole in the graph. Letter D is the only graph that is continuous because you can absolutely draw that without lifting your pen. There's no discontinuities, there's no jump discontinuities, removable discontinuities, infinite discontinuities, etc. So just as a reminder, that's the jump discontinuity. This is the removable discontinuity, a removable discontinuity, and then you have continuous for part D. So in calculus, this is not the definition that we use. We have a more mathematical definition, but this part one of this video series, I just wanted to remind you what continuous looks like, and then we'll get into the more formal definitions that calculus uses. So this is the last part that we'll look at in this video. This is the second set of graphs, and again, there's one graph that's continuous. Go ahead and try to find that right now. So part E is not continuous. If you were drawing that, you would be lifting up your pencil at x equals 2. This is an infinite discontinuity. Part F is not continuous, right? There's that weird little piece, and then you definitely have to lift your pen to get to the next piece. Part G is the continuous graph. You can draw that without lifting your pen, no discontinuities. And part H is also not continuous, right? You're drawing that, and you would have to lift your pen to draw the next part of the graph. Okay, so hopefully that helped you just remember what continuity looks like, and then we will develop our definition in the next video. Great job.